got a chance to chat with some of you guys. Thanks for braving it over here, because we're going to talk a little bit about the distributed enterprise. And I had the pleasure of talking to some of you, and it's all about the fact that you are actually operating multiple locations. And multiple locations today, obviously, is how we do things. Why? Well, because computers are so much smaller and so much more powerful that we can create autonomy in each of these locations. So I'm going to give you a little bit of technical insight, a little bit of framework on how we actually achieve that. So just real quick, the lawyers want us to flash this. You don't want to read it. It'll guarantee to put you to sleep. But one thing that's really important for us is if you can please give us the feedback. It does make a big difference for us. So with that, all those housekeeping things out of the way, let's get to it. So like I said, most customers like yourselves have a distributed enterprise, which means it's not IT in the old data center anymore. It has actually shifted out to a bunch of centers of data. And you start going, oh, that was clever. Did you come up with that, Dennis? No, I didn't. It was our CEO that came up with that a couple of years ago, observing that indeed, as we're making the computers more and more powerful, we can also make them smaller and distribute those. So they can be everywhere you want in a retail operation, and each store is running on what essentially is a little data center for a center of data for each store. And if we do it for cruise ships, as you see over here. So everywhere there's human activity, there is actually a chunk of data processing. And why is that? Well, not surprisingly, because we human beings, we have a lot of jobs to do, and these jobs that we do is actually all creating, well, what do you expect? A bunch of data. That's precisely right. Everything is creating data, and that data needs to be processed many times in real time. If you're in retail, right, and you're using cameras to stop people from robbing you blind, well, that thief, once he's done his dark deed, fake scanning or secreting a drill or whatever it is he's stealing, he wants to get out of the store. So by the time you see the event and the time you intercede and stop the thief, you have seconds to react. You don't have time to send the data somewhere else. That data has what we call data gravity. It's actually sitting at that location and needs to be processed right there and then in as close to real time as possible. Why am I saying this? Because we hear a lot about AI at the show, but it turns out we've been using AI for facial recognition, behavioral pattern recognition, foot traffic, all that stuff for quite a while now. And all that is driven by the data. So of course, we like to talk about AI and we realize, well, wait a minute, AI is actually just a workload. It's a workload like any other workload, except it uses GPU, higher bandwidth networking, higher performance storage, and all those things are all things that we need to update. If we have old gear, old systems laying around, we need to update that so they can run the AI workloads in real time. So you can imagine, this is all a function of milling or mining or extracting the value out of data. So let's take a look at what has been going on with data. You heard from a lot of folks, oh, data's exploding. I think that's the wrong way of thinking about it. An explosion, when I was a little kid in Copenhagen and ran around, we had these big Chinese firecrackers, and we put extra twine around them and shellac, and we dried them, and we let one of those go off, it'll go bang! Right? And the entire apartment complex, the windows would rattle, and all these old ladies will go out and yell at us and go, you little devils, we'll call the police, right? So that was an explosion. That was a bang. Is that what's been happening with data? No. I have not seen it getting quiet after that bang. I see data going more and more and more. More and more data is a good thing if we can mine it and make value out of it. So it turns out, when you look just the last 5 years, the amount of data AI is driven now is actually 1,250 times more than the data you just had a few years ago. And now you say, well, that's fine, but I have more powerful computers, so I'll just send it up to a public cloud. Turns out, no, you can't, because the public cloud has not gotten the bandwidth. It's not that the public cloud doesn't have the compute, it just doesn't have the straw size to move the data from point A to point B. We did a little experiment ourselves with quality assurance for the service that we assembled to order, and it took 21 seconds to send it to another data center and get a result back. We didn't have 21 seconds. We actually had only 1 second. So time and data is a big deal. The more data you have, you have still the same amount of time, maybe less time, you need to put the processing close to where the data is. And if you see, is that getting worse or better in the next couple of years? And the answer is, it's actually getting worse. So when you look at the shortfall, not only today there's 11x shortfall in comparison between bandwidth between sites and the amount of data in each site, in the future, it'll be 35 times shortfall. So you begin to see this data is not an explosion. It's a relentless, everlasting geometric expansion, yeah? And more data is good. That's why people say, oh, data is the new gold, or data is the new oil. No, because gold is finite, oil is finite. We humans, we create more and more data. We're the ones actually creating more and more resources, and this is the gift that keeps giving, if you can make sense of it. Okay, good. So let's talk about what do we use to make sense of it. Well, it turns out, I just told you this for a second here. I was looking at the wrong monitor. All right, so to make sense of it, we need a computer. So if you look at how fast, how big is these computers today? A computer today is actually unbelievably fast compared to just a few generations ago. And you who have been HPE customers for a while, you know that we actually have gone from Gen 9 to Gen 10 to 11 to 11 plus, and now Gen 12. What can you say about those servers? Do they have more or less cores? You can shout out, more cores? Yep, show of hands. More cores, right? So they're more powerful. Did it cost a lot more? No, not really. So the price has stayed constant, but it's actually turned out that you get more bang for your buck with the newer servers, which is why we replace older servers that don't have the throughput, doesn't have the cores, doesn't have the parallelism to do the job, with new servers that can do the job better and more efficiently, and also we can cut down on power consumption. This is very important. So think of it as a unit of measure, and it turns out today's servers are actually 16 times more powerful than they were just a few years ago. And if you go to the turn of the century, what used to take us 26 racks to do a given job, with one U-High servers, 32 of them in each rack, we can now do it in a single server. So imagine that. So unbelievable, like computers have gotten powerful, they've gotten small. We used to call it, honey, I shrunk the data center. Right, that's exactly what we're doing. And then at the same time, it's not just getting more cores in the system. What has also happened, of course, as you know, is we have shifted the way we do compute in terms of its paradigm. We moved from a sequential kind of thing, like SQL Server, email servers, that kind of stuff, back-end office stuff. It was very sequential in nature, that's how the stuff was written. But when we put a GPU in a server, we get massive parallelism. And we don't put just one GPU in a server, we actually put 1, 2, 3, 4, 5, 6, 7, 8. And you start going, oh, no big deal. No, it is a big deal, because the GPU is a very, very hungry little beast, and it eats a lot of power and needs to be cooled. So there we are actually expanding now to water cooling, which I saw you can see over here on the show floor. It's really quite exciting. We can think of a compute machine as a data in, power in, business value out. Yeah? And today the business value is entirely as an AI server, because the workload now requires you to have GPUs. Now if it's retail, and I know the gentleman in the corner there, we talked about retail, 450 stores, you might just only need one GPU to feed 20 cameras in a small location, but it turns out there's a camera to GPU to server ratio, and we just scaled that as a recipe. Does that make sense? Yeah, okay, good. So we're moving now from the old paradigm of having a data center, which was sort of my private single site cloud. Everything was the corporate data center in Chicago or wherever it was, Copenhagen, Stockholm, to now moving to a whole new idea. The whole new idea is a distributed paradigm. We're seeing that everybody is operating multiple locations, but it's the same company and it's the same control sphere. So we need to create a private distributed cloud. And a private distributed cloud has all the benefits and the control of a data center, and all the benefits and ease of use and agility of a public cloud. For example, if you want to stand up 10 more workloads, but you're finding out that the location in Chicago can't do it, you can certainly move them to the other locations that you have in New York or maybe Seattle, because you're operating a distributed private cloud. And once you have that distributed cloud in place, you can use public cloud availability zones as overflow. Making sense? So this is what we call a private cloud first strategy. And so of course you won't be surprised for me to say, and that's where GreenLake comes in. There are many of you who may have said, oh yeah, we heard about GreenLake all the time, you guys talk about it all the time. GreenLake in the back of the day was a way for me to pay for something. Yeah, it started that way. It started as a consumption-based system where we then eventually realized if we're going to manage the systems for purpose of consumption, we can manage them for everything else. We can manage them for workload, we can manage them location, availability, all that. So what we're seeing now is we're seeing the emergence of GreenLake having different availability zones in your private distributed cloud. And those can be augmented with public clouds. Let me just get a little bit of the vodka they gave me over here. And I'll tell you, the reason that this is important is you need to manage this as a continuum. Your data and your workloads go across this whole picture. This is where you want to take a picture. This is one of the good slides. Hang on, let me have a little sip. And let me talk about an example. So healthcare, right? Many of us move around. We live in maybe Seattle, then we move to Chicago, then we live in New York, then we move to Florida, whatever. And every time we go to a doctor, we get a new doctor, and your medical record has implications as to how you will be treated if you indeed need to go in for a procedure. If some of you had the experience, I certainly have, was quite cool from a data management standpoint. If you do a whole body scan, known as a PET scan, I thought I was going to bring my dog and have him scanned, right? No, not that kind of PET, right? It's an imaging thing where you get an isotope injected into your veins, and then you lie still as best you can, and then you slowly are scanned. What they're doing, it sounds a little macabre, but what it is, they're slowly giving you as picture of you in slices. And all that data yields 2 terabytes, one patient, 2 terabytes worth of raw data that is then stitched together like a movie. And what the doctor does is he or she rotates the picture of you to see if there's anything wrong in your body. And they can turn you upside down, all electronic. But you now have a footprint, right, of 2 terabytes worth of data. Now let's say you get that done in a clinic and your local doctor needs to see that. Well, now we have a challenge. How do we actually work on all this globally distributed data? Or you move from Seattle to Florida, right? We still have a data footprint, and it needs to follow us. Very important thing from an IT standpoint. So how is this achieved? Again, private distributed cloud. Let's take a look. Oh, I'm clicking on the wrong mousey button. All right, check this out. So if you're a hospital or a clinic location, what do you have? You have doctors that use cameras, X-ray. In the case of the scan, the PET scan mechanism, it's all data. Little server sits next to it, yeah? And you aggregate all these servers into an aggregation little data center in a can, and this could very well be a GreenLake private cloud, something like that. Or if it's needing a GPU, which is highly likely, you probably need to go private cloud AI. And that then reports back up to aggregation across all the locations. Why? Because a hospital, hotel, retail, manufacturing, they're all the same distributed enterprise. So we need to look at it from where's the data coming from, how do we aggregate it, and how do we aggregate across all the different zones like we just discussed. So how is this actually done? Well, it's done by taking a thing like an edge computer. You can see the DL145 over here. Those guys are so cool and so nice and friendly. You just bolt them to the wall, and they'll take care of all the sensors and cameras and whatever else that's in that location. These used to be big Sun workstation machines back in the day. Today we can do it easy peasy in a 60-core machine with up to 3 GPUs in that little machine you see that says location 1, 2, 3, 4. And then the zone management in the hospital or in the city for all the retail operations there is then bubbled up to a cluster that manages the health of all these distributed devices. And that then in turn is turned into the estate management that is now where you would log in to look at GreenLake. So that's done at some central location. You can host it, or we can host it at a public cloud, but you log in and view your entire estate this way, yeah? That's why we see a lot of maps in GreenLake pictures, right? Because it shows you where all the stuff is. So if you have a control plane, what's the other thing you need to have? A data plane. And what do we use there for the data plane? Well, you won't be surprised to hear, we use the data fabric, right? So we have a distributed data fabric, but we have one unified global namespace. That means a doctor in Seattle can gain access to the data in Florida. because he can see the files. And if he then needs to move some of the files, he can do that too, or he can leave the files there if it's better for him to process that wherever the GPU is. In other words, the data goes where it needs to go, but you need to have a control plane, and you need to have a distributed data plane. Does this make sense? Okay, I'm hoping it's not making too technical. So how does this actually work? Well, you would realize that GreenLake then has to be a technical stack, and it's all about your application. Everything else is just a necessary evil. So what's the necessary evil in this case? Well, let me lift the veil here. Take a look, and here as you see from the bottom up, and this is very important when you are working with us at HPE. We're an IT outfitter. We like to talk about gear. But what you use the gear for is the whole reason we have a discussion about the gear. So we need to start with networking. If you're a distributed enterprise, get the networking squared away right after you're done squaring the power away. So I'll use a retail operation. You open a new store, you put power into place, right? Next thing, you put networking into place. After you put networking into place, you now start putting in the compute and storage nodes that are attached to that network. And then SD-WAN. Now it's beginning to sort of look like Christmas, right? You're building from the bottom up, all the hardware. But you don't stop there. You actually have an OS or hypervisor, and you hear us talk a lot about, now we have HP virtualization now with HP, HP VME. It's tough to say all these acronyms. VME, right? So VME is actually a Kubernetes implementation that is managed by a Morpheus control plane. It's all part of GreenLake, yeah? So that's the next step up. And then you have data management. That's the stuff we do with Certo. That's the stuff we do with Espal Data Fabric. That's the stuff we do with all the stuff you hear the storage folks talk about. And then workload, what kind of workload are we talking? Bare metal? Are we talking things like perhaps a VM? A lot of folks use VM still. And obviously with the new HPE virtualization, it actually turns out to be much more cost effective. And it can be containers. Show of hands, how many people here are rolling containers already? Yeah, you see, you're already there. So what we're finding is some people started with VMs and they're working their way into containers. That's actually where it gets really nice, that it runs on the same OS. That's not the case with some of the alternative hypervisors, because they require you to run Kubernetes inside the VM. We don't do that. We run Kubernetes on the OS right next to the KVM implementation. So it's more efficient. Yay, we like that. And then, of course, the workload, finally, the applications are instantiated as workloads. So all those layers underneath, they need to be up and running right. So as you heard us talk about this, we are actually now putting agentic AI in across the whole stack. So having a stack, knowing how the stack layers are connected, that gives us unique insight into how to optimize for what we call stack alignment. In other words, the stack needs to be with the right amount of bandwidth for the workloads, right amount of storage, the right amount of IOPS, the right amount of latency, all that. You cannot solve that problem if you only looked at networking, or if you only looked at storage, only looked at servers. You have to look at all of it together holistically to be able to suss that out. So if you hear us say it simply, there is an agent for everything in GreenLake. That's exactly right. So you start saying, well, okay, that sounds good, but have you guys actually created a stack of which you speak? And the answer is yes. And this is not stuff you necessarily will see in a GreenLake demo, but I'm trying to get this a little more technical, that this is actually what's happening underneath. So the networking obviously is Aruba, right? We know that. And it might be something more in the future, which I can't talk about. And it turns out ProLiant, Electra, that's storage and servers, you know them well, and they have maybe GPUs in them. At least the ProLiant servers do. And then we have Ubuntu as the OS. And on top of that, the data fabric. Electra software, so you know Electra expands all the way to public cloud. So there's Electra data management software. And then Certo for continuous data protection. So now everything has their home in the layer cake. And why is this important? Because you go home and talk to your team. Without a layer cake like that, you'll find your meetings are becoming less productive. Because you're sitting around talking about networking stuff, and another guy comes in and wants to talk about storage stuff, and you're talking past each other, yeah? So having this to say, oh, wait a minute, Jimmy, we're talking networking right now. Well, we need to understand how that connects to your storage. Oh, so we hop to the storage layer and so on. So we're finding this internally to have been a very huge help for our internal teams to navigate what is essentially a rather complex stack at this point. Now, all this is lovely, but your CEO probably doesn't care. So how do we translate this into a CEO kind of initiative? Well, we need to introduce the OODA loop. And an OODA loop is some military concept that was actually set up a long time ago and by the military in dogfights. And he who has the best information and can react the fastest have an advantage over somebody else. So think of this as a loop. It starts with you observing. You need to have instrumentation so you can observe stuff. That's what IoT was all about back in the day. And then we need to make sense of what we see with the sensors, cameras, temperature sensors, events, so on. And then we take action. And it's the action where the money is, right? And action is sort of like being pregnant. You can't be 50% pregnant. You either have a child or you don't have a child. You either buy a car or you don't buy a car. You either ship that pallet of machine parts or you don't ship that pallet of machine parts. So it turns out everything we do is indeed binary, right? So how do we get to calibrate the right binary decision? We do this by traversing this loop, getting the right sensor information, diagnose things correctly, and then finally taking action. And the faster you can do that, the better. And this is what you use, this observation. As you can see, I'm adding structure, technical structure to the internal discussions in IT. If you then go to your CEO and say, how do we increase agility? How do we increase security? How do we increase sustainability? These are individual OODA loops with individual set of sensors, with individual set of diagnosis capabilities, and individual actions. Now, for those of you cats who have really been paying attention, you go, well, wait a minute. These can be automated, yes, and then it's agentic AI. Ha ha! How smart is that? And when you start thinking about this globally as a distributed enterprise, you have these agents pop up over everywhere, creating value for you, talking to other agents, and basically creating I would say, a hairnet of intelligence in the theater you operate. Cool. So now that's really what GreenLake is aiming to do today, is helping you with your users, your applications, your developers, your data, the stuff that you care about that runs your business. And then from an IT standpoint, we're giving all your end users, with GreenLake, we're giving them a self-service platform. So they can log in themselves, provision if they have the rights and they have the budget. They can provision their own 10 VMs to try out some. They don't need to go to AWS anymore. They use your own private distributed cloud. And GreenLake is smart enough to find out where there's free resources laying around that we can use for 10 new VMs. Or if we don't have any, well, we'll let you know that too. It's time to buy some more hardware. The point being, you are now responsible for the workload lifecycle. You are responsible for the data lifecycle, and of course the infrastructure. Do we have the right servers? Do we have the right network? Do we have the right storage today and in the future? Now, I will say this, you are not alone. You are together with us. We will build it with you. We will even run it with you. So when you see it says you and HPE there, we're working together. And I'll tell you, we're just having the pleasure of talking to Sune from Danfoss, and that's exactly what Sune shared with us. He said, we love it. We work with you, designing this, running this, for at least 6 years at this point, as long as I've known him. So this is really cool. This is how we make sure you get to your objectives. Because at the end of the day, GreenLake, it is your cloud, your private cloud, your mission, with your data, your location, all the 450 locations you have, right? And it's your choice. If you want to run Nutanix on there, fine. You want to run Red Hat on there, fine. Anything you want to do. It's open, it's extensible, and it's entirely under your control. So this is your choice, your control, and it's completely without compromise. It's not like you go and say, oh, well, we want to run Nutanix on this stuff, and we go, yeah, we don't support that. No, we support that. If you say, I still want to run VMware, we support that. If you say, I want to run VMware, and then I want to move to this HPE VM that you're talking about, well, fine, we'll support that too. So it is completely open, completely extensible. So this is it. So with that short conversation, I think I'm close to being out of time. I have like 5 more minutes, but thank you so much for your kind attention. Cool.